Good morning, Pradeep. Welcome to Mathematics Hot House.
Good morning, sir.
We will continue with our geometry. Okay, where did we stop? What did we do last in geometry?
Give me a moment, sir. I'll just see this up.
Yeah.
We stopped with theorem 7, sir.
Theorem 7. Please tell what is the theorem? Theorem 7.
If two triangles have three sides of the one equal to three sides of the other, each to each, they are equal in all respects.
Yes, so this is the triple S test. So we continue. We will continue geometry. So we proved the triple S test for congruency of two triangles. Earlier we also proved the SAS test. Do you remember the proof?
Yes.
Okay. Did you do the exercise on page 22 and 23?
Yes, sir. It is 22 23 theorem 7 and so on.
So you need to see the exercise continues on page 24 also. So you need to courier the geometry solutions and all other homeworks to me. Okay, do it ASAP.
Yes.
We will continue further. So theorem 8. The statement of the theorem is as follows. If one side of a triangle is produced, if one side of a triangle is produced, then the exterior angle is greater than either of the interior opposite angles. So here goes the diagram. Whether you call it diagram or construction, it is one and the same. Let ABCB given triangle, and let BCB produce to D. So this is A, B, C. C produced to D.
Yes, sir.
The diagram must be drawn stepwise, okay?
Yes, sir.
So now always keep in your mind what is to be proven, and sometimes it helps to write it, okay? So it is required to prove that the exterior angle ACD is greater than either of the interior opposite angles ABC BAC. Now suppose E is the middle point of AC. Suppose E is the midpoint of AC. Why can we assume this? We can assume this because earlier when we were developing Euclid's geometry from scratch, there were several postulates. One postulate was that if a line has finite length, it definitely has a midpoint. Okay? So E is the midpoint. Now join B. Join B. So that's what I am doing, joining B to E. Then further produce it to F, making EF equal to B. Okay, so we produce it further. Call this point as F. Mark these segment B equal to segment B. Then join FC. F and C are joined. Okay, done?
Yes, sir.
So now we start the proof. See, now in geometry, once again I am clarifying for you. In plane geometry, Euclid's geometry, the foundation course, we will not use any algebra. So whatever operations we do will be geometric operations. Just as in algebra we multiply by a variable or divide by a polynomial. So what are the operations permitted in geometry? This is one of the operation permitted, producing a line segment in either direction, taking midpoint of a line segment, drawing a line perpendicular to a given line from a point lying outside it, drawing a line parallel to a given line from a point outside it. This is also that fundamental assumption, Playfair's axiom, which we will learn. Follow? So in geometry we have to do some constructions which will aid us in proving the given theorem. So these geometric constructions will not come all of a sudden, by divine intervention. They come by practice, by imagination. Okay? So we proceed further. I am redrawing the diagram. Okay, have you copied, beta?
Yes, sir.
So now we come to proof. In triangles AEB and CEF, in triangles AEB and CEF, AE is equal to CE by construction. Okay, because E is midpoint. E is midpoint. EB equal to EF by construction, and the angle AEB is equal to vertically opposite angle CEF. So we can mark them. As we write the proof, we can do markings on the diagram, which will give us further hints how to complete the proof. Therefore, triangle AEB is congruent to triangle CEF by SAS test, which was the first congruency test we proved for two triangles. Okay. Therefore, angle BAE is equal to angle FCE. Okay. But
So your video is not visible.
okay, hold on. Okay, I will disconnect and reconnect.
Okay, sir.
but angle ECD is greater than angle. By the way, backtracking, angle BA is equal to angle FC, congruent parts of congruent triangle, CPCT. So angle ECD is greater than angle ECF. Why? What, Pradeep, why? Angle ECD is greater than angle ECF. Look at the diagram.
1 second, sir. Because CF is the bisector of angle ECD.
Ram. Who has ever proved it? Okay, anyway. Listen. Have a look. ECD is this angle, right?
Yes, sir.
And a part of this angle is angle ECF.
Yes, sir.
So can ECF be greater? It is a part of angle ECD. Can it be greater than it? No. A part cannot be greater than the whole. That is the common sense reasoning used here. So we have to write that, because a part cannot be greater than a whole. WHOLE. Which implies angle ECD is greater than angle BAE, which in turn implies angle ACD is greater than angle BAC. You agree with these?
1 second, sir. Yes, sir.
Okay. So we continue this line of reasoning. In the same way, if AC is produced to B, if AC is produced to B, is produced to G, I apologize, is produced to G, as shown by supposing that A is joined to the midpoint of BC, it can be proved that the angle BCG is greater than angle ABC. But angle BCG is equal to vertically opposite angle ACD. Therefore, the angle ACD is greater than angle ABC. Then you write down like this QED. That means end of the proof. Okay?
Yes.
Did you understand each and every step?
Yes, sir.
Now we come to a special case of the theorem, which is called a corollary. Corollary means a small theorem which can be quickly derived from the given theorem. Corollary 1. Any two triangles I apologize, it is any two angles of a triangle one second, excuse me.
Yes.
So corollary 1 says any two angles of a triangle are together less than 2 because Supply missing steps here. Homework. Corollary 2. Every triangle must have at least two acute angles. Because if one angle is obtuse, or a right angle, then by corollary 1 each of the other angles must be less than a right angle. You agree? Pradeep, are you paying attention?
Yes, sir.
You agree with this?
So, but previously it is meant that any two angles are together less than two right angles, sir.
Two right angles means 180 degrees.
But here, okay, sir.
See, understand it this way. What does it say? Every triangle must have at least two acute angles. That means the number of angles could be one acute, or n equal to 2 acute. Sorry, at least 2 meaning n equal to 2 or n equal to 3 acute. Okay? Now, if one angle is obtuse, what happens? Obtuse means greater than 90 degree. Then by corollary 1, each of the other two angles must be less than a right angle. See, if you take x plus y plus z equal to 180 degree, okay? Now, what did I say? 1, let us say x is greater than 90 degree here. Then y plus z should be less than 90 degree. Only thing is, we are not allowed this algebraic reasoning. We are using pure geometric reasoning. Follow? This is the beauty of the what we call, what I am trying to teach you, axiomatic deductive logic. If you recall, I always emphasize that we start from basic axioms, definitions, and deduce. Meaning because step 1 is true, implies step 2 is true, which will imply step 3 is true. This is the meaning of deductive, deduce or deduce. Follow? Okay. So now corollary 3. Only one perpendicular can be drawn to a straight line from a given point outside it. So this can be a technique, geometry technique. Okay, just as we use constructions, we can use these arguments in proving other theorems in plane geometry. So the answer is because if two perpendicular lines could be drawn to AB from P, we should have a triangle PQR in which each of the angles PQR, PRQ would be a right angle which contradicts this theorem or its corollaries. Okay, so the diagram for this would be something like this. I am drawing it in dark brown in the middle of the board. This is A, this is B, this is the point P lying outside it, Q, R. Is it clear, Pradeep?
Yes, sir.
Okay, bye bye now. And the next exercise is homework. Okay, the homework is due tomorrow morning.
I see.